Hi, my name is Kennedy Young, and today I'll be explaining the procedure of my fingertip damage project number 2. For this project, we will be calculating two properties, modulus of elasticity and the Poisson's ratio. These two properties are useful in calculating the damage used for a fingertip because they can calculate the deformation that will happen to a fingertip of long-term use on smartphones as the smartphone increases these days. The other things that we need to calculate these properties are the stress on the fingertip, as well as the lateral strain on the fingertip and the axial strain on the fingertip. When I decided to come up with my procedure for this project, I thought it was really important to use things that everyone had around their house. Also, looking at other people's entries for their project, I wanted to be a little bit different. That is why I used a piece of paper, a pencil, and water for my experiment. In my procedure, I dip my finger into water and then I put it on a piece of paper. I would do this with ink, but I didn't have anything with ink around at the time that I was doing this project, so I decided to go with water, and I thought that a lot of people that did this would also have water around, therefore that is one of my resources. I feel like people always have paper around and a pencil. I think that this is an easier way to measure the width of your fingertip because it's circular and it's easier for people to use a ruler on paper rather than a caliper on their thumb. The first step of this procedure is to take the thumb or finger that you use with your smartphone most often and gently dip it in water and then put it on a piece of paper, like so. Then, carefully circle that print. Now that print has been traced, take your ruler and measure the major and intermediate diameters. Once you have your fingerprint traced and measured, this is your major diameter, while this is your intermediate diameter. Take those calculations and use the area of an ellipse to get the area of your finger. The next step in this process is to take out your scale and make sure it's zeroed and make sure it is in grams. Then set your phone on the scale and zero this out. Then apply the same amount of force to your phone as you normally would. Once this levels out, record that value and do this about 3 or 4 more times and then average all the values. Once you have taken all these stresses, average them and then multiply that by 0.981 to convert this into force. Then you will take this value and divide it by the area that we used these values to calculate. The next step in this process is to use your thumb and your caliper to measure the height of your thumb just sitting there with no force applied. Once that's taken, then put your finger onto the scale and push the same amount as you found before, which was around 35. Once you do that, you'll measure the height of your new thumb with the force applied. You will then take these values and subtract the initial height minus the final height divided by the initial height to give you the axial strain. The next step in this procedure is to find the lateral strain on your fingertip. First, you're going to dip your finger into the water, as shown before, and trace it. This time, you will do it very gently, applying no pressure. The second time you do this, you will then put your paper onto your scale and dip and push the same amount as you have for your previous trials onto the scale. You will then measure the width of both of these different trials and subtract those two. The initial intermediate diameter minus the final intermediate diameter divided by the initial immediate diameter will give you the lateral strain. Once you have done this entire procedure, you will then use these values that you've come up with to find the MOE and the Poisson's ratio. These two values will help determine the deformation that is happening to the finger with the iPhone or the smartphone use. Thank you so much for listening to my video, and I hope these work out for you.